Good morning.
Good morning. Good morning.
It's great to see you. Everybody have safety glasses? My first question of the day. Okay. Once you get on the shop floor, they're required, so once you go through that door, they become a required accessory. I'm Paula Martell. I'm the Human Resources Manager for Easton Machine. You'll be touring this morning with our president, our vice president, and an alumnus of your school. Mike Medeiros is our production manager. We'll begin with two groups, one starting on this end of the shop and one going out and across the parking lot and starting in shipping and receiving. That way it gets you closer to the machines and you can generally hear what your group leader is saying. A group of this size altogether would be too many for the kids in the back to hear. And some of the spaces between our machines get a little tight for large groups. When you're finished with your tour, you will return here. We have some gifts for everybody, and then we have a couple of door prizes that we'll give away in a drawing, like a raffle drawing. So I'm going to give you a little time to take a look at the display. It's some parts that we make. There's an opportunity for you to be the quality control inspector and tell us which part isn't made to print. And then there's a variety of prints. My explanation of the prints is not really for you guys. All day today there will be people coming through from the public, from the government, teachers from non-vocational schools who are coming to hear about what we do. And I want them to understand what the engineer is communicating to the machinist in a blueprint. So maybe you guys can take a look at that. And there's a group of parts, completed parts, and parts cut in half for inspectional purposes to go with those prints. So take a little time, walk through. There's some statistics about manufacturing in Massachusetts running on the television, and then we'll organize you for the tour. Okay?
Come on out, guys.
And the sophomores are going to go through this door.
Come on in.
I like this uniforms.
Right. I like it. The collared shirt, it's a nice touch. So throughout the scope of this tour, if you guys have any questions for me, please feel free to ask. I am a Diamond graduate. I do remember back my time in the trade school, actually precision machining wasn't really my first choice. And I placed into the shop and I thought to myself, oh geez, what am I going to do with this now? But I realized looking back that it was more of like a blessing in disguise, because I've continued to apply myself, and I've been out of school now 13 years and I haven't seen a single day of unemployment in all that time. So, and you guys now coming into it really have the advantage, because I don't know the exact statistic, but there's a growing number of what we would consider incumbents, which are just people that are already working in the industry that are retiring. And there's just not enough skilled guys that are coming into the field to make up for that gap. So if you guys stick with it, I really think that you have the advantage coming in. It's more of like the world is your workplace come the future, because the skills are interchangeable. Whatever you're going to learn here or at other shops, you'll be able to carry along with you. So with that said, I just want to, I want to add clarity to anybody that might have questions today or concerns, whether or not they want to stick with it post-graduation. So with that said, I can show you guys, this is, we'll start in the front of the building, which is part of our Swiss department. These machines are some of our smaller capacity Swiss machines, and by capacity I mean the diameter in which we can run through it. These have a 3/8 diameter capacity. They're Swiss style machines, which I'm not sure, do you guys have Swiss machines in the shop? So the way a Swiss machine will compare to that of like a conventional lathe that you might be familiar with, where you have a chuck and your tools might approach on a tool plate or a turret. The tools will move into a position but then remain stationary, and the stock will move into the tool to generate whatever profile that you wish to cut. So if you guys want to come on over, we can take a look in this one. We have this one open. It's real tight quarters, so I'll meet you all on this side. But yeah, we can all factor through here and take a peek. It'll be easier as we get out back because the equipment is much larger. But another capability of these machines is they have a sub-spindle assembly that allows them to take a part that we might not necessarily be able to finish in one operation, hold it on the back and finish it so we can drop parts off complete. So if you guys want to take a peek in here, and I'll come down this end, you feel free to take your time and look in. Sorry, Kevin.
That's all right.
Getting in your way?
No, not at all.
This is a very similar model, what he's setting up now, just a different style bar feeder on there.
Like that machine is set up for demo.
It is for a demo? Awesome.
Yeah. Brush some oil across the tools and
Okay, it's already over there?
open.
Will do. So all of our Swiss style machines are equipped with these magazine style bar feeders. And what they allow us to do, I'm just going to open the cover. This is one of the older style bar feeders, but what it allows you to do is the bar feed interfaces with the machine so that we can run what we consider a lights out unattended. And as the bar is getting shorter and shorter as we process it, the machine is constantly communicating with the interface in here, and it tells it, okay, there's no more material remaining. So it will automatically come back, extract the remnant, they call it, just the leftover bar, load up a new one, and the machine will continue to cycle without any interaction from an operator. So invaluable when it comes to running lights out and trying to remain competitive and profitable in today's industry. What Kevin has set up for us over here, he said we have a demonstration. This one is not necessarily a Swiss machine. It has a fixed headstock with tools that move into play, kind of like a turret, but on a very small scale. So what we can do, hopefully we don't get blasted with oil. If we do, we'll take it out on Kevin. We'll splash some oil over here, and then we can cycle start. So now this wouldn't be an example of a Swiss style machine only because the tools are moving into the cut and the stock is remaining stationary.
So like gang
Yeah,
tooling?
right. This machine is one of our older pieces of equipment. I actually think it's a 1996 or so. So you can imagine with, 5 years ago, cell phones were for calling only. The way there's that perpetual motion in technology, how far machinery has come in that much time. Mr. Valerio has told me that you guys have upgraded to some Mazaks and other machines. So she's not the youngest girl at the prom, but she has her purposes. So we'll go ahead and head down now into some of the larger switch machines. Thanks, Kevin. Down here we use this bench mostly for assemblies, secondary op inspections if it requires you to look underneath some magnification, things like that, assembly. So if you guys want to take a minute and look through this, this is a component that we're actually making for Starrett tool, which I'm not sure if your school uses their micrometers, but this is basically a sub-assembly of what I would probably consider to be like a specialty depth mic, but we make all the components for the exterior of it. We have it here in an assembly drawing if you'd like to take a closer look at it, and this is some of the other products that we do in assembly. If anyone is interested and you want to take a look at through here what these parts look like, this is an optical enhancer. It's called the Mantis. You can magnify things up to 10 times. Really gives a good color image through. So if anybody's brave enough and they want to sit down and take a peek through, feel free. I'll give you a minute or so. So all it takes is the first guy that everybody follows.
Well, I warned them ahead of time not to touch anything without permission. I'm all gun shy.
You're right.
You notice how neat the benches are? I want you to notice that as we go along, how everything is organized. Not like No, they got a vernier case open, and we try to put as much chips in there as possible. You're not gonna see that here.
No,
right?
we do pride ourselves on the
Exactly.
cleanliness. I don't know if you're going to see that at every company. You might go to another company and find that it's leagues ahead of us in terms of cleanliness.
No, this is pretty good, man.
We do a good job though at keeping up on these things.
Sometimes
Yeah.
they find the biggest pile of chips to put the micrometer on.
Right.
And,
Or back in the day when they used like Speedy Dry, and they put
Right.
Speedy Dry over oil, and you'd go home standing on mountains of dirt. If you want to bring it up to a focus point, you can pick the part up and carry it to a lens. And that'll help you to zoom in. Yeah, it takes some getting used to. But in terms of ergonomics on your back and neck, it's a much better system than trying to look through a scope. So this is typically the noisiest area of our building, only because we have a lot of secondary finishing operations like tumbling, burr removal. But this piece of equipment over here is our mirror clean. It's an Aqueous style automated cleaning machine. So the hoist that you see is completely animated up above. All we do is place a pan of parts on the end that we wish to clean, select a program that's appropriate for it, whether you're doing aluminum, brass. There are certain things that you want the machine to do and not to do. We just tell it that information and hit start, and you can walk away, and that hoist will carry it through each chamber, cleaning it along the way until it'll dry it in that last station on the end and place it up on top, at which point all we have to do is remove the basket and it's done. So it's a really nice machine. I don't think it'll move. Actually it will. So if we give it a few seconds, you'll see it's going to move both baskets at once, and you can get an idea of just how the machine will function. This machine in the final rinse tanks tracks contaminants or particulates to the parts per million, so that when we clean the parts and we give them to the customer, we know to at least a per million scale the parts are clean.
Burrs is important, right?
Yes, absolutely. Whatever you can do on the machine is critical. I'm sure once you guys get out in the industry and you start working with companies and they explore different lean options, they'll go over things like that, how the minimal interaction between operators, it will benefit you more in the end. So you might want to absorb a second or two in machine cycle time to benefit to not having 10 seconds of personnel time working on it. But there is always that instance where you just can't quite get that burr off. The crane moves slow. It moves at one speed because I guess it would be like in the algorithm of its design. It's fail-safing itself to carry any product, whether it's delicate, it doesn't matter whether it's a hardware screw or a medical instrument. It's trying to take its time and carry it along so there's no nicks or dings added to it. And then where we can go from here is I'll show you the smallest Swiss machine that we have. We'll walk out back this way. So this machine, we can all gather around down this end. This machine is like a specialty, I guess you'd call it, Swiss machine. its capacity is 3 millimeter max. So under 1/8 diameter will fit in this machine. It's for really small components. We've done some things on here. I'm not sure the end customer's name, but they would actually go into cell phones and they work almost like I guess it'd be like a gyroscope where, you know, you tilt your cell phone and your screen moves from portrait to landscape. Well, there's a mechanism on the inside through like fluid transfer that tells it whether or not you're in portrait or landscape. These parts were so small and intricate that you could fit 3 or 4 of them in the letter C on a penny. And it's a whole new hurdle of obstacles when you're machining that. How do you catch it? How do you inspect it? Things like that. So I think there's really only 2 or 3 shops that are on the East Coast that have one of these. It takes a delicate hand and patience to run, that's for sure. It's a Sagami based Fanuc. I'm not sure if the Mazaks that you guys are running are Fanuc based.
Not the Mazak.
No, is that like a Mazatrol? Okay. All right, so
We only
these.
have one Mazak.
Okay.
We have a couple of lathes.
Okay. So maybe not so familiar with it yet, but it uses conventional G and M codes that you guys will learn a little later. And then as we come down this way, these next 2 machines are like the big brothers of the 2 small ones you've seen out front. Those were the 10 millimeter capacity. These are 20 millimeter capacity. So just double in diameter, but you can see how much more workspace that you have when you're working in. So I don't know if you guys can all see in there, but what we have is a tool plate in which all the tools are mounted. Those will remain stationary, and the material itself on the inside is what will jog in and out of the tool. And that is the main difference between what you might be accustomed to in a conventional CNC versus the Swiss style. We have one machine down in the corner that when we get there, we've outfitted it with a clear cover so that you can see all the machine's motions in action, and that'll be a good time to see how it actually works. This machine is the newest one we just acquired a little less than a month ago. We don't have it up and running yet, but if you want it, it's a tight squeeze, but if you guys want to file in and take a peek, it uses a conventional lathe style turret to carry tools and a gang slide like on these Swiss machines. So it's like a combination of both. You can Swiss machine if you want, or you can park it and go conventional. So if you guys want to go ahead and take a peek in, we have the door open. This will run up to 1.5" stock. The live tooling of the machine is so that if you were working on an operation like a drilling that's not about the center of the part, so your tool itself has to be rotational to do the cut, these machines, all the Swiss machines, are outfitted with specialty holders that'll rotate the tool, and you can leave your stock stationary. They all have different ranges in terms of RPMs. Like these will max out at around 5,000 to 8,000 RPMs, whereas that small machine, the PO3, we can go up to 50,000 RPMs, which is really good when you start running drills. We run drills on that machine that are 10 thousandths in diameter, 8 thousandths in diameter, and you really, if you were to actually look up the correct surface footage for it, it's like damn near approaching infinity. It's so fast, so we just typically max out the RPM to get it going. Some of these here, all the remaining 4 machines in this aisle are Citizen style Swiss machines. They run a Mitsubishi controller, which is much more user-friendly. The controls on them allow for you to quickly handle things, whereas the Fanuc, you have to have a good understanding of Fanuc to get it going. With Mitsubishi, you just need a basic understanding and you can usually get things going. But if we can go down to the door where it says exit, that last machine is set up for demo, so we can take a peek in. What I'll do is I'll one cycle it and let it stop. And we can open up the door, you can take a look in, and we'll get an idea of how it's actually moving. If this was running a brass job, I'd go ahead and shut the oil off so we could get an idea of what's going on, but I believe this one's a stainless steel. It's not going to be very forgiving if I run it dry. And the guy who set it up wouldn't be happy with me if I did that, so. Yeah.
Is that the print for what they're doing right now?
Yep, that's the part that's currently running in here. And it drops right out the end when it's done. So you can see through here, we have the spindles that'll move. The sub spindle will go ahead and this will primarily work down here with the bottom tooling, and it's going to move in both the X and the Z axis to cut any turn geometries that you want. Up here, this gang plate will move into a position, a fixed position where it's centered, and then your stock will move out and do the turning. Hello. So the slide that moves has no influence on any Z depths on the part. It just goes into position and then the stock will move in. The noise that you're hearing now is from these pumps. They're a high pressure pump. They allow us to push the coolant onto the cutting edge at, this particular pump will do about 2,000 PSI onto the edge, and it helps to evacuate chips, keep temperatures down. Really important when you start running some of those high temp alloys like the titaniums and nickel-based gummy materials. So the next area we're going to go through, I would typically go in the mill, but the other group's there. So what we'll do is we'll go through the lathe section. This is some of our bigger equipment. It's the conventional mills that you might be accustomed to seeing outside of this one here that's going to have a robot on it to help load. But it's also the older equipment in the shop, but again, don't judge a book by its cover. Those machines are workhorses. They're probably early 90s models, and they still work and hold tents. So why don't we take a peek at this first, the one that has the biggest footprint here. Yeah, we can go to the other side. This section is basically just a centralized tool crib for setup use. We keep all our collets and tooling over here. But along this back wall is some of our optical equipment that we can inspect features with. Do you guys have any optical?
We do have
Okay.
optical comparator. Yeah.
So this one, we don't have a part here, but I'm going to grab one and I'll show you what it looks like underneath the image. Sorry. Excuse me. Sorry. So this part for one of our customers is a windage screw. It goes on a rail system for like an AR-15 for if you want to adjust sights. But when you look at it underneath this comparator, it's not just a black and white 2D image per se. It'll give you a realistic view of what you're looking at, and it comes equipped with all sorts of functions that if you want to check the diameters of holes, things like that. It's a really nice piece of equipment.
What's it called?
This one's called the Ram Optical.
Ram Optical?
Ram Optical, yep. And I mean, you can use crosshairs to check diameters, circles. It has a 2-circle function in case you want to check like how concentric 2 diameters were. It's a really nice piece of equipment. If anybody wants to jog any of the handles around and get a feel for it.
It indicates whether it's been on the edge or off the edge. A hole?
Not this particular model.
Okay.
We do that. Just by sight, you'll line it up and zero out. So we could, if you wanted to know the diameter across this knurl, you could come up to it and zero out your axes readings. come down to the opposite side, and we got about a 561, so that 9/16 or so.
Okay, yep. We have a fiber optic one where it'll indicate whether it's on the surface or off, comes off.
Oh, okay, like a Smart Wizard or...
It just indicates that it's on the surface, off the surface.
Huh.
Yeah.
Interesting. I don't think I've seen that one yet. Is it equipped to, like, say,
So yeah, similar to
Okay.
screen like that. Yeah, projecting on the screen and
Okay.
viewed surface. But we're looking to upgrade our inspection area.
Right.
Our next goal is upgrading that.
Yeah, that's
You guys
it's
see 'em, man.
pricey.
We
It's
still
definitely
haven't
pricey.
seen them, but that's the next.
We don't have a CMM here either, but they are a nice piece of equipment.
Right.
What we can do is we'll just pit stop quickly into the quality office, then we'll take a look at the mills and the conventional. So Mr. Valerio was telling me that you guys have a few Haas CNC mills. Have you guys had any exposure to them yet? As juniors? No? Okay.
I'm sorry.
They haven't run any of the CNC mills, right? Yep.
No.
As juniors? Okay. So our milling department is comprised of these two machines here. They're Fanuc robo drills. This one's equipped with a pallet changer that allows us to shuffle work that's done out and place work that's waiting to be done in the machine so that the machine can continue to run while an operator takes the finished part off and prepares it to work again. So the downtime is limited or eliminated altogether. So if you guys want to, I don't know, Paul, do you mind if they take a peek in for a sec? You guys can have a look in. It's an entirely different environment than what you've seen so far in the Swiss. You have your tools are all approaching from the top down vertically, and the plate itself, the pallet, is going to move to cut any of the profiles, the geometries that you want. So there's an extensive amount of startup time when it comes to mill, because you have to worry about how you're going to manufacture the part, how are you going to fixture the part. There's so much, he has to design the fixture also. So what he has set up over here on his computer is a CAD CAM rendering of what he's drawn up to produce the parts that he's setting up now. Yep, and it is cycling. So we can head this way. I'll show you both the Wasino and the CAD CAM that they have. So that program there is Gibbs Cam. There are many different varieties of CAD CAM software, but it still requires the interaction of somebody to program it. You would go ahead and draw it up, tell it what kind of tool paths you want to cut, tell it what tools you're going to use, and then it simulates it all out for you. The benefit of that is that you're checking for crashes, potential issues on a computer screen in 2D, not on the machine in live time, you know, where it's really costly. So it's a nice setup and valuable. It's another end of things that you guys would learn if you continued in manufacturing. This last area is our CNC lathes. They're all conventional. This one has the option of both a bar feed or a carousel with a robot loader. So I believe I can just hit cycle start and I can show you how it works, but the goal with everything in manufacturing is time. Yeah, that's what I know. The end result is we're giving a product, but we're selling the customer time. So the best way that we can do it in the littlest amount of time makes us the most profitable, the most competitive. So this robot armature that's on the backside will carry work waiting to be done in, load it into a CNC chuck, take the finished part out and drop it on the carousel for inspection. Okay, so you might not all be able to see it from over there, but I'll run it a few times. But the carousel's coming up now to check the height of the bars that are in there. So at that point, it would have dropped off a finished slug, but there isn't one in it. So what this robot allows us to do is take a job that would have been a chucking job, where you would have to sit there and open the chuck, put a new part in. And now we no longer have to do that. So the air blast will clean it out, make sure that we're not going to crush on chips. Loads the new one in. And then it'll come over. It'll begin to drill and do what it has to, and then the cycle will start over. So if you guys want to, we're going to end up going that way, but it'll allow the guys down this end to take a peek if we all scoot down. What's important with the robot is that every single movement that you're seeing is programmed. There's no set method for picking up. It's all designed by the person that's setting it up to do every single X, Y, the close, the open. So each part has its own unique program. That movement that you just seen it do where it came up and moved over, that is because sometimes if you get two slugs of material that are oily, they stick together and it might lift two. And if you have two load in there, it's going to make a loud noise. And then again, that's the finished part.
So we're gonna run the one cycle, so just hit the cycle stop and you guys can
Yeah,
come up?
I'm just cycle starting once.
Okay, good.
Okay.
Because I had it on continuous over the poles.
Okay, yeah, we're heading that way now. I only did a one cycle twice.
Oh, okay.
Twice. All right, so it gets a little tight again, but we'll head this way. We're starting to get to the older equipment. The remaining machines that we have down here do have live tooling, but they're very limited. This one in particular doesn't. This is a turning, threading, drilling only machine. But if you guys want to take a peek in, it might be something that you're familiar with or used to seeing. These last two machines are almost identical. This one's a little newer than that one, but basically the same features on the inside. This one does have live tooling again. As you can see, we're going to be tapping, but we're going to be tapping in the X, so your spindle will have to be stopped and you'll synchronize up using a floating holder that gives you a little bit of leeway in case the machine can't quite move the pitch exactly. Will flow to tap in and out. Otherwise, it's a standard turret machine with a collet set up. And this model is the exact replica of this one. This one's currently in cycle. You guys can feel free to try to take a peek in. The oil smashes up against the screen pretty heavily, so. All right, we can all try to fit out here. So this is basically, we did the shop in reverse, but this is basically where the adventure begins for the team that works out on the floor. Once we, if we quote a job and we win it, we'll order material out front, and then when it comes in, we store it in this rack here. Now I know looking at it, it just looks like we take material and we stuff it into the next open hole on the rack. But this is actually very meticulously controlled by Roberto, who's sitting behind you. Every single material is documented for, its size, its alloy, what it's going to be used on, how many feet, and it's all documented on all these tags that you see, and also electronically in the computer through what we call an ERP system, which is it's accessible to everybody on the floor. Think of an ERP system as like a computerized manager. It tracks everything that's in process that people might want to know information. So we've got the information in 2 locations. And then once we receive a job, we'll send a notification to Roberto. He'll grab the appropriate material and place it on those staging racks out there, the 2 racks that you see, for the machinist to come grab. What that also gives us is control over which materials we have, because we're I don't know if you guys are familiar with the term, but we're an ISO 9000 company. So we are ISO compliant. ISO is like an international system of standards. It's an organization that issues standards throughout the world for quality purposes, so that records are retained long enough. So like, let's say, what's your name? Ryan. Let's say Ryan, in a few years, he ventures out and he opens up an oil rig company. And Ryan calls us and says, hey, I need this part. It's going to work underwater. It needs to be non-corrosive, and not corrode, and it needs to have a special coating to prevent it from being impacted by the salt water. So he calls us. We order the material, we make the part, we give it to Ryan. Ryan calls us back in a year and says, hey, that part fell apart, my oil rig's underwater. What did you make it out of? Because of ISO and the standards that we have, we'll be able to look back and show us a material certification of what it was that we ran per the customer's spec. So it both helps us in instances like that. That's a really bad example, but it's an example of what ISO is about, and repeatability, continuity, making sure that what we give them the first time is what we give them every time. And what we'll do is we'll walk right through into this last office, and I'll introduce you guys to the gentleman that handles all the quality aspects for us. So you guys can come on in now. And we can cycle as many people in. We're going to end up backtracking that way, but all right. So before we head on back up front, this would be the last area that we haven't looked at. This is the quality assurance department. Inside here is usually home to Aaron, who's sitting in the back. He's our QC inspector, and Frank, who's not in here at the moment. He's our quality assurance manager. So between each of them, their roles are to make sure that we are up to date and compliant with the ISO 9000 regimen that we have. So right now, our certifications up here, we're ISO 9001, 2008. We're going to be upgrading soon to the 2015, but they're basically the front line for questions that we might have with customers, or if customers have questions for us. Frank, being the quality manager, will handle those communications directly. And between each of them, they also make sure that our measuring equipment is in calibration. They'll do first article inspections, or first pieces, so that we get an extra set of eyes looking at the machines before we go into production. And they'll do any necessary final inspections or in-process inspections, depending on which customer we work with, because we have a diverse product line that we make for. So some customers, if they're medical based, require higher inspection levels, or if it's government, higher inspection levels. So between each of them, they make sure that we're doing it accordingly. If I catch Frank in passing, I'll introduce you guys to him. But otherwise, we'll begin to head that way. We'll send you back up front.
How important is the ISO certification? What if you didn't have it?
Well,
what would that mean?
If you didn't have it, your sources of revenue from customers are going to be very limited,
that's right,
because the end customer is looking for the certification. And what we have as ISO 9001 is like I'm not an ISO expert, but it's like a broad version of ISO. There are the tail end numbers, I believe you can change to accommodate, like the medical industry will have its own set of ISO procedures that you follow, aerospace. So it'll draw down into specific concentrated versions of ISO. But when the customer calls and that's the first question out, are you guys an ISO compliant company, and you say no, you're losing work.
Exactly.
So it is very important. I don't know offhand of any employers at this time that aren't some type of ISO certified. If they are, they're probably more of like a mom and pop kind of setup. Not that there's anything wrong with that, but they're not going to be able to compete with the other manufacturers that are in terms of quoting. So, yep, we can go ahead and we'll head this way up front. I think Paula has something set up on demonstration for you guys. That's probably the next group that I have to take. So what I'll do is I'll grab, well, there's more coming in. So there's a little bit of confusion, but I think I'm taking the next group out. So this might be the end of the road for our tour today.